So associative learning involves sort of linking, associating stimuli with each other, predicting and responding to expected outcomes based on available stimuli, and your own past experiences with these stimuli. And, it comes out of a philosophical tradition of these, what are called British associationists, like David Hartley and John Stuart Mill, in the, 18th and 19th century, who thought that simple associations provided sort of the mental building blocks for more complex ideas and behavior. But of course, Ivan Pavlov is a Russian physiologist who won a Nobel Prize as well. He won the Nobel Prize in Physiology and Medicine in 1904 for his studies on the nervous system control of digestion in dogs. And these are kind of grisly experiments. He would, basically, before Pavlov anyway, it was thought that the passage of food, sort of down the esophagus and into the stomach would sort of physically squeeze out gastric juices. And Pavlov actually severed the gullet and attached both ends to the skin of the neck. And so he would introduce food into the stomach and it would just come right back out. But he noted that it did cause release of gastric juices, even if there was no direct, esophageal sort of connection down to the stomach. It's a grisly, again, kind of experiment, and I have two dogs that are part of my family. So this was sort of a reflex arc for digestion, all carried out via the nervous system. But then he discovered famously that just the sight of the food alone, could cause the release of gastric juices and of course famously salivation. Even the sight of the person who generally brought the food, would also provoke salivation. And the swirling of gastric juices, release of gastric juices in the stomach in these dogs. So he did these famous, what are called classical conditioning experiments with dogs and bells. And he discovered that the neural circuits that underlie complex processes like digestion, in response to the presentation of food or stimuli associated with food, they could be modified by experiences, by learning. So it's a form of memory, and it suggested the sort of plasticity, which is a fancy word of saying the sort of modifiability of these nervous system circuits. So there are various aspects to classical conditioning. There is what we call acquisition, and this is repeated pairing of what's known as a conditioned stimulus. So this is going to be, let's say, the famous bell, that is presented right before you deliver what's known as the unconditioned stimulus. This is the food. The food, without any conditioning will provoke salivation. But now you're going to pair it, with the presentation of a bell, which is the conditioned stimulus. So repeated pairings of the CS, the conditioned stimulus, and the US, the unconditioned stimulus, something called the unconditioned stimulus, so UCS, over multiple trials. That's the acquisition phase of a classical conditioning experiment. You can also do things like, for example, then later on you present just the bell, the conditioned stimulus, and then the dog, Pavlov found, would actually salivate without any presentation of the unconditioned stimulus. So the dog had been conditioned. Now you have what's called a conditioned stimulus, and the salivation in response to the bell, to that conditioned stimulus, is called the conditioned response, right? So you can do a couple things in these conditioning experiments. If you stop pairing, the presentation of the conditioned stimulus, the bell with, the food over multiple trials, you can extinguish the conditioned response, right? Yeah, this is called extinction. You get less, response and less response to the bell. And what's really fascinating about that is we've discovered how this is not like forgetting. The dog doesn't forget that the bell once, predicted the arrival, of food. It doesn't lose that association. It appears to be that there is new learning that is, sort of overlying that existing association. For example, if you just were to delay, the test. So let's say you do an set of acquisition trials. You pair the bell, the conditioned stimulus, right, with the food, which is the unconditioned stimulus, and you get the unconditioned response initially, which is, just salivation, and then over time, lots of, acquisition trials, lots of pairings of the CS and US, you get, a very reliable, you hit the bell, conditioned stimulus, and you get salivation, a conditioned response. And then you extinguish. You do a lot of time just presenting the bell, no food, bell, no food, bell, no food. And the salivation response goes down, 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 down. You've got extinction, right, of that response, right? Well, then you just wait. You wait a day, and then you come back the next day and you hit the bell. Well, what do you think happens? It turns out that typically there is what they call a spontaneous recovery of the conditioned response to that conditioned stimulus of the bell. So that's, again, some evidence that that extinction is not forgetting, but it's just sort of new learning over, that period of these extinction trials. And that this is something really interesting because if you think about how we get conditioned and we make associations with various aspects of our environment, how, you may, when you return to an environment, in which there were powerful associations, even if those associations had weakened, have been extinguished because you haven't been presented with the CS and made it the CR over a period of time. When you go back into these environments, you can have powerful what's called renewal. This is the renewal effect. And this is particularly relevant in, for example, studies of drug use disorders, like, somebody who, responded very powerfully to stimuli in a particular environment, let's say a bar, and they would enter the bar and order a drink, right? And then they go into recovery for an alcohol use disorder. And, there's no more alcohol. They don't get that association. They extinguish that association, right? There are strong kind of drug treatment efforts to extinguish that specific association, right? But yet, when they're released, they go right back into the old neighborhood, and that bar is still there. And they're going to be very, powerfully drawn. There'll be what we call renewal, basically of that association. So classical conditioning experiments have been, utilized, quite a bit. There are aspects of what we call stimulus generalization, right, where, for example, the bell that Pavlov used in his study, maybe it went like bong, right? And then it would, multiple acquisition pairings, it would provoke a conditioned response of salivation. Well, if you did bong, like a slightly different bell, sometimes that would still provoke, the salivation response, even though it was not exactly the same, bell. That's called stimulus generalization. And I want you to think about, are there experiences or episodes or moments where you feel that you've been conditioned, to give specific responses, and then you generalize, in certain circumstances, where there are stimuli that are similar but not the same. And then there's also what we call stimulus discrimination, right? Where if it gets like a buzzer or something, it goes too far, beyond the initial, conditioned stimulus, the response drops off completely. So can you imagine how aspects of stimulus generalization and stimulus, discrimination work in our own experiences in our own lives? And do you feel that there are moments, or there are experiences, or there are, examples of classical conditioning, that is actually that you've participated in, that you've been conditioned, to respond to specific stimuli?